It could be.
Okay, so again, if you turn it in late, you're gonna get a 0. So you've got 13 seconds to hit submit.
Or number 1.
Yeah,
It's not C. It's not A. It's not C. It's not B.
A or D.
All right.
It's D.
Okay, let's go through these. Let's see if I can. What do I make?
I got one.
Okay, number 1 is tricky. That's the one that has taken you guys some time. So they're telling us that we have this function f of x. They're saying g is the inverse. G, that means if f goes through the point, or, well, if f goes through AB, then g goes through BA. So we know the x and the y switch on an inverse function. They're asking us to find g prime at 3. So that tells us that the x coordinate of g is 3. So therefore 3 is the y coordinate of f. So that's all I know. G prime at 3, the rule is with an inverse, it's going to be 1 over f prime at whatever the corresponding x value is. So this would have to be a. So what takes a while is finding that a. So you have to think, okay, well, when does the function f equal 3? This is where your calculator is going to commit. Your function f of x is 3x cubed plus e to the 4x. When does this equal 3? We're supposed to solve for x. How can you solve that equation for x? What was that? So it's do 2 things. Yeah. So I would put this, so you guys go ahead and follow along if you haven't already done this. It sounded like a lot of you weren't sure. Graph those two, y1 and y2. Okay, so go into your y1 equal your y1 screen. Break this down and I'll do the same. Okay. Okay, so I've got it in as y1 and y2. There was no window really, so I'm just going to do a standard window. I don't know what mine was last. I'm just going to hit zoom 6. What am I looking for? Yeah, the intersection, and you need it to be exact, so you don't want to just approximate. So you're going to do second calc. You're going to choose intersect, which is number 5. Yours, the questions are different than mine. On the calculator, it says first curve, second curve, guess. Hopefully our answers come out to be the same. You guys will have to tell me, did you get 0.448? Oh, 0.269. Sorry, that is what I have. Mine, I'm just looking in the wrong spot. So this 0.2697. Okay, we're going to store that value. I don't know if it's going to work as nicely on here. So I'm going to go to my main screen and then check and see. No, mine has the different x value. What was it? Mine will be close enough. 0.2696. Okay, 97. Oh, let me also go down a little row. 0.2697. Did I type that in right? Yeah. So I'm going to just hit store as alpha A. You guys should have hit X and had all of the decimals, but mine will be close enough. Okay, so now we know that A value. I'm going to go back to here. So we know that this was 0.2697. Yep. So now we know that x value, that's the x value that has to go here. So it's going to be 1 divided by f prime at that x value. So I'm going to take the derivative of y1. F was y1, so on my calculator, I'm going to do math 8. I need the derivative of y1 evaluated at alpha A. Not sure if this app is going to, you guys agree? You get 12.419. This isn't our final answer, but do you get this at this point? Or no? I got a yes. Why is this not my final answer? It's not the inverse. I have to do 1 divided by this. So far I just have the denominator. So I'm going to do 1 divided by my previous answer. You get this? That answer there? Yes? Okay, so our answer 0.0805. They rounded it to 0.1. So, or A. So the answer is A. I knew this one was going to be tricky. That's why I wanted to put it on one where you guys could talk about it together. It is extra credit, but that's a reminder of how they can take something that we're pretty good at. We're pretty good at taking derivatives of inverses, and then they make it hard on a calculator-like question. Okay, number 2 was mostly memorization. You guys recognize this one? Based on the options, it looks like it's probably sine or tan inverse. Which one is it? Good. So the rule is if you have sine inverse, if you're integrating sine inverse of u over a du, then that's equal to, sorry, wrong way. If we integrate 1 over the square root of a squared minus u squared du, then it equals sine inverse of u over a. What's a? What is it? 2. A is 2. U is simply x and du is dx, so it works out perfect. So our answer is just sine inverse of x over 2. So the correct answer was B. Okay, so we'll continue to do these starter questions. The one thing I want to do different is we're going to start doing more group work. Sorry, so if you go back into the modules for today, under today's date, you're going to see that link for 3rd try group request. Okay, as we start studying and preparing for the AT exam, which is our main objective for 3rd try, I think it's super important that the structure of the class has to change and go away from direct instruction, like away from me just teaching you guys to you guys working on the problems together. And I'm going to kind of do more support than like helping you guys through it. So tomorrow, I think I will put you guys into groups. So you will sit in groups. Oh, I have to sign in and that you guys shouldn't have to. But if you click on this, if you wouldn't mind doing it either now or at least by lunchtime so I can make the seating chart for tomorrow. If you click on it, it's going to ask you 3 questions. The first one just says, what's your name? The second one just says your class period. That way I can sort the spreadsheet when I get it back. And then the third thing, just list names of students that you'd like to work with. I want them to be students in this class period because it's going to be like who do you actually physically meet with. You guys who are online, you can choose people who are physically in class. If you guys know somebody who's doing it online and you want them to participate with your group, then write their name down too. Like if you would feel comfortable having your phone, like with the Zoom meeting, so you can communicate with them so they can get that support too. Go ahead and do that. Okay, so again, it'll be groups of 4. I say that this is a request because I may not honor all of your requests. Like if the 4 strongest students in the class all ask to be together, I might say no and want to spread you guys out. Okay, so this is a request. I might put you with 1 or 2 of the people that you request, but if you'll put those in, I'll have a new seating chart, like a new seating arrangement tomorrow. Okay, and then the other thing, it won't go. Okay, so then on the home, you can also open up the 3rd trimester disclosure. I'll bring you around a hard copy. But a couple things do have to change this trimester. For one, we're not going to have a final. We're only going to have 2 tests because we just have a test this Friday, which covers our unit 8. And then we have 1 last unit. And then we start reviewing. So the structure of the class changes a little bit 3rd try. And with the emphasis on groups this trimester, You're still welcome to like do online when you need to do online, but if you have a tendency to be like, oh, I just don't want to go to school today, I'm just gonna sign in online, I think it will be harder third try if you're like going back and forth. If you're always online, or you're online for like 2 weeks because for whatever reason, then that's fine, but if you can be in person, it will make it easier. So, okay, so first thing, AP test is May 5th. So that's a Wednesday. I believe it's the first of the 2 weeks of the AP testing. How many of you are taking other AP tests? Just a handful? Okay. So it's kind of nice when our test falls in the first week because then you get it over with as opposed to like having to stress out all your others. So I like it being in the first week. We'll be ready for it then. We will do a practice exam a few weeks prior to the actual exam. Tentatively, I think that date is going to be, the nice thing is with Fridays, it used to be in years past. Most years I have to make you guys come in on a Saturday and take up 4 hours of your Saturday. Now I get to just take up your Friday. So I think that's going to be April 23rd. So on Friday, April 23rd, we'll have a practice exam. You guys will come in. You'll sit an entire AP practice test. We'll go talk about the format, but there's multiple choice, the free response, we'll grade it. You can see how you do, and then that gives us 2 more weeks to kind of finish, you know, tweaking what we need to study for so that we're ready for the AP exam. Okay, assignments. In the previous 2 tries, assignments have made up 20% of your grade. It's been a 20-80 split. I switched it a little. It's going to be a 30-70. The projects is because after the AP exam, we're going to do a project. We have about 3 weeks after the AP exam. So we'll do projects after that. We'll talk more about those details later. But that would go in this category. The other thing that's going to change is we have 3 more weeks where like the structure of the class is pretty much the same. This week we have our Unit 8 test. So your test is on Friday. Then we have 2 weeks of Unit 7. We have 2 weeks as we cover Unit 8. Okay, so 2 weeks from this Friday would be your last unit test. Then we'll have 5 weeks of review. During the time when we're reviewing, instead of getting a daily assignment, you're going to have an assignment packet for the entire week. So you'll only have to turn 1 thing in per week. But that means that there are fewer assignments. So I definitely will not be dropping any homework assignments, because if I let you drop 2 of them, that'd be 2 whole weeks worth of assignments, which I'm not going to do. Okay, so no assignment gets dropped third trimester. Instead, you will receive a late pass. This will allow you to complete an assignment and without having any late penalty. The late penalty is the same thing. It's 10% per day until it gets to 50%. But on those weekly assignments, often the weekly assignment would be worth like 150 points. So you don't want to turn that in late. So you can have one late pass. The best thing to do is to wait until the end of the try to decide which late assignment to apply it to. You don't want to apply it to today's assignment, which is only worth 20 points. Even if you turn that in late, you're out 10 points. If you turn in a packet late, then you could be out like 75 points, right? So it's probably best just to hold on to that until the end of the try, and then at the end of the try, you'll let me know which one it will be. I'll send out this link later as we get closer to it, but if you go to the disclosure online and you click on that survey, that will link you to the survey. The survey is just where you're going to tell me what assignment you want to apply to. Now, if you turn in all of your assignments on time and you don't need a late pass, then it counts as 10 points extra credit. So that's your best option, is just don't need a late pass. At the end of the try, you can tell me, just apply it to extra credit. Again, the projects we'll talk about after the AP exam. The assessments, the one thing that's different here, let's see, I guess there's not really, I'm going to drop 1 score from this. It could be the test or it could be the quizzes. So it's just 1 score, but again, there's not a final to replace your lowest score. So there's only 1 score that can be dropped. This trimester, you'll have 200-point tests, Unit 7 and Unit 8. Once we start reviewing, there will be a 50-point like mini test or quiz every single Friday. So every Friday there will be a 50-point assessment. So it's kind of a combo of a quiz and test. You'll have 1 free response and like 8 multiple choice. So it'll be kind of like a half a test. And one of those can be dropped for the trimester. Any questions? Everything else should be the same. I think in the modules I've added, I haven't. I'll add an assignment there where you can upload assigned disclosure. Yeah.
Are those quizzes?
No, maybe once, maybe occasionally, but not for the most part. For the most part, you'll have to do it on your own. Yeah. So the extra credit, we won't do the group extra credit like the outside of class stuff. I think once we're sitting in groups, the extra credit will just be embedded in the class, those first couple questions at the beginning of class each day. So you don't have to do something else in addition. That's how you can earn some extra credit each week. Okay, any other questions? So again, if you haven't already, please make sure you fill out that group request. If you have no preference, you're welcome to just say no preference or just leave it blank. Or if it's like you need to sit towards the front, feel free to add like other comments in that box too. Okay, let's go through 7.3. So we'll go to your notes now. So in your notes, today we get to do slope fields. So a slope field is just little tick marks that indicate the slope of a function at that point. So we're going to sketch some of them today. And then I mentioned projects a minute ago. There's that project back there next to Eric on the cabinet, like at the top, it has the green and then kind of looks like the sun, the mountain, the sun in the sky. That's a slope field. So a student created a slope field. What we're doing today, they did that for their project. And if you go look at it closely later, you'll see all the little tick marks. And then they show the equation that they created that from. So that's kind of what we're doing today. It's going to tie in nicely with what we've already done this unit with separation of variables. So it just says a slope field is a graphical representative or representation of a set of slopes obtained from a differential equation. So looking at example 1, they're giving us this differential equation. The differential equation is just an equation with the derivative. So they're telling us what the derivative is. And they want us to evaluate the derivative at each of these points. So all I'm going to do, I'm going to take the dy dx. They told us dy dx is negative x over y, and I'm evaluating it at the point 3, 2. Okay, so again, that vertical bar just means I'm evaluating. That means I'm plugging in 3 for x and 2 for y. If I plug in 3 for x and 2 for y, I get negative 3 halves. This is the slope. That's what dy dx equals, right? So that's the slope at that point. So if we look at this grid, if I go over 3 and up 2, there's the point 3, 2. Here's this tick mark. The slope of that line is negative 3 halves. It's negative 1.5. You can tell it doesn't need to be precise. You will be expected to sketch some of these sometimes. It just has a negative slope, but it's a little steeper than 1. So just relative steepness is what matters. Okay, so then if we try the next one, again, it's just plugging in x and y into our derivative. So I'd have negative x, so negative of a negative 1 over the y value, or 1/3. So the slope at the point negative 1, 3 should be 1/3. So I'm going to go to the graph, negative 1, positive 3. There's the point negative 1, comma 3. Look at that line. You see how it's not very steep? Still has a positive slope, but 1/3 is not a steep line. So that line has barely a positive slope. It's increasing really slowly. Okay, if we try the next one, we have the point negative 2, negative 1. Again, I'm still just plugging it into there. So I have negative x, so negative of a negative 2 over the y coordinate. So that gives us 2 over negative 1 or negative 2. And if you look at the graph, again, back to negative 2, negative 1, there's the point. Negative 2, comma negative 1. The slope of that line, you can see is pretty steep. It's a pretty steep negative slope. So when I grade a slope field question, I'm looking at, does it have a positive or a negative slope? And in terms of like, is it steeper than the ones around it? So just relative to each other. Okay, go ahead and do the last one, do D. That one, when you find the point, you go over 2, down 2, that point does not have a tick mark on it. So that means they want us to fill it in. So we're supposed to do a slope of 1. That's just, it's a 45-degree angle. We've got that tick mark. Not bad. See if you can finish this slope field. What I mean by that is all of these points that don't have tick marks on them, see if you can fill out what it would be. So if I were to do one of them, let's say I were to do this point right here. That point right there, what's the ordered pair for that point? 1, 2. Then I plug 1, 2 into the derivative. Well, the derivative is negative x over y, right? Yeah, so if I plug that in, I'd have a negative 1 over 2. Then when I draw this line, it's negative, but not very steep. Make sense? They can be a little bit tedious and time consuming when there's a lot of points. It takes a while. So I'll give you guys a minute, see if you can finish filling out the rest of those. So every dot has a tick mark. Notice there are not any dots along the x-axis. We'll talk about y in a second. So just the ones where there is a point are where I want you to fill it out. You might notice some patterns that will help you fill it out faster. Your subfield should look something like that. You guys notice any patterns as you did this that made it a little faster? What were some of the patterns? Yeah, Milo.
So on the fourth quadrant, top row, like 1, 2, 3.
Uh-huh.
I forgot the.
Sorry, say that one more time. I didn't hear you.
So on the fourth quadrant, top row, the second one was 2, and then that third one was 3.
Good. What other patterns did you guys notice? Good. You guys see how, like, once you kind of do it, you see that there's, it looks like this is a whole bunch of circles. You guys agree? So there's kind of a pattern to it. A couple of things that I noticed, since the derivative, since dy dx was equal to negative x over y, I always like to look for 0 slope. So when I'm looking at this, I'm thinking, okay, well, when will the slope equal 0? Because 0 is really easy to graph. That will equal 0 anytime x equals 0, right? 0 divided by any number is 0. So all along the y-axis, when x equals 0, those would be horizontal tick marks. Okay. Notice there are no points along the y-axis. Along the y-axis, along the x-axis, y would be 0. What would happen if we let y equal 0? Undefined. An undefined slope would be vertical. We don't sketch it, but if we kind of go with what Sean said a second ago about this being a circle, if we sketch the circle, you see how it would be vertical right there. So it is approaching a vertical slope. So it says here, why can't we find slopes when y equals 0? Dy dx would be undefined. Because we would be dividing by 0. Okay. one other pattern that I noticed with this that helped me, and it's one that happens a lot, is I'm looking for where it equals 1. I can tell that this slope, look, this slope is going to equal 1 whenever x and y have opposite signs. If x is positive and y, well, opposite signs are the same number, so like 2 and negative 2. If they're the same but opposite, it's going to have a positive slope. So all along right here, well, like 1, negative 1, negative 2, positive 2, negative 3, positive 3. All of these slopes along this are a slope of 1. Going this way, anytime it's 1, 1, 2, 2, if the numbers are exactly the same, if x and y are the same, then it's negative 1. So all of these slopes are negative 1. There are some patterns that can help you like sketch it faster and answer other questions. Okay, so we've already done example 2, we've sketched the whole thing. Example 3 says, okay, so now that we see a slope field, we want to sketch a particular solution. Just like we're going to find particular solutions, we can sketch a particular solution. They want us to start at the point 0, 1, and then follow the flow of the slopes to sketch a solution to the curve containing that point. So I'm going to go to the point 0, 1. So 0, 1, there's the point 0, 1. And we're supposed to sketch a curve that goes through there. Now, it's tempting to do what Sean said. It looks like a circle, right? It kind of looks like a circle. A circle is not a function. It fails the vertical line test. So we want to sketch it so that it still is a function. So we can only graph the top half of this circle. So I'm following the slope fields. Okay, I knew that at the x-axis it had to be basically vertical, that undefined slope. Had a radius of 1 if we go up, so I predicted going this way it's going to be 1, so that's the particular solution. Now, technically there are open circles here and here because dy dx doesn't equal 0, so we're just going to talk about that interval in between. Okay, so that would be our particular solution. Then we'll do another one. So then it continues, and it just says our solution curve must represent a function. So again, meaning it has to pass the vertical line test. That's why we can't sketch the entire circle over the largest interval containing the given point. So just make sure you don't sketch too much of it. The next curve they want us to sketch, they want it to go through the point -1, +1. So I'm going to sketch a separate particular solution. So I'm going to find the point -1, +1. So there's the point -1, +1. And I'll do the same thing. My graph doesn't have to be exactly precise, but it's just going to look, I don't know, something like it, probably go through that point. Something like this. We're just looking for a basic shape. These questions do come up on the AP test, and all they're going to look for is it about the right curve? So if it's approximate, you're going to get it. Okay, so those are 2 particular solutions. Okay, what type of graph does that seem to be producing? What is the top half of the circle? Anybody know what that equation would look like? Okay, let's keep going. We'll see it in a second. Okay, and then this note is important. It just says the most common student error in sketching a particular solution is to extend the graph too far or create something that's not a function. So again, where a student might create the whole circle, or so it's important that you have appropriate boundaries. So in this case, the x-axis is the boundary. It's anytime you have that undefined slope, you can't really cross it. So I'll continue to highlight that. Okay, so if you flip the page on example 4, that's the exact same differential equation we just sketched the slope field to. So now we're going to tie what we just did back to what we did, I guess it was 2 weeks ago, when we were solving differential equations. Step 1, we need to separate the variables. We need to get the y's on one side and the x's on the other. So I'm going to multiply by y. If I multiply by y, I'd have y times dy equals -x times dx. So it's this process of separating the variables. After we separate the variables, we find the antiderivative of each side. The antiderivative of y is y squared over 2. The antiderivative of -x, we get -x squared over 2 and then plus c. Okay. Right now they have not given us a particular solution like a point, so we just want to solve for y. So we want to get y by itself. What would we do at this point? Times by 2. So if we times both sides by 2, we would get y squared. Those 2's cancel out. The 2 gets multiplied by a constant, but 2 times a constant is still a constant. So I can just say y squared equals negative x squared plus c, because it's going to cancel out with that too. We're okay there. What's our last step to get y by itself? Good. What do we always have to remember when we take a square root? Plus or minus. Now I just thought, did I graph that last one? Did I pop the wrong point? No, it was up there. Okay. So what it's saying here is it says, no, solving for y yields two equations. Yeah, ours is two equations. It's either a positive square root of this or a negative square root of this. You guys have had some practice choosing which one it is. So we're going to kind of look at this. Okay, they want us to find the particular solution to this differential equation that passes through the point 0, 1. How do we find the particular solution if it passes through 0, 1 when we're doing it analytically like this? What do I do at 0, 1? Plug it in. So we're going to plug in 0 for x. We're going to let y equal 1. I have two equations though. Which one? Do I choose the one with the plus in front or the one with the minus in front? Plus. Why the plus? Good, because y is positive. If y is positive, we have to go with the one with the plus sign in front because the square root is always positive. So I know I'm going to use that equation. So in place of y, I'm plugging in 1. In place of x, we're plugging in 0. And then we can solve for c. So I can square both sides, but I get 1 equals c. So we get that the constant is 1. So our equation, y equals our particular solution, is this. If we were to graph this, so if we were to graph negative x squared plus 1, this equation is exactly what we graphed right here. That is, the top half of the circle is just the square root of x squared in the number. So it's taking that. Okay, so that gives us that equation. So that ties it back to what we sketched was the graph of this function. Okay, we're going to do the exact same function, but a different starting point. This time they want us to use the point 0, negative 3. This is saying x is 0, y is negative 3. Do we use the first equation or the second one, the one with the plus in front or the one with the minus in front? Minus. If this is negative, if y is negative, you have to choose the one with the negative in front. Otherwise, if you can't, it would never be negative. So we have negative 3 equals negative square root negative 0 squared plus c. If we solve this, we could divide both sides by a negative and just get rid of the negative. Square both sides. So 9 equals the constant. So our final answer, y equals negative square root of negative x squared plus 9. Well, this equation, I'm going to go back and sketch where I think it would be on the graph. This was the point 0, negative 3. So if I come back to the slope field, I'd go 0, negative 3. There's that point. This would just be the bottom half of the circle. Radius is 3, so something about like that. And that would be the particular solution. Negative, it's below the x-axis. Not too bad. Okay, so really that's all there is to it. We're just tying in like a graphical representation of what we've been doing. All right, on example 5, first thing that bothers me is they wrote y prime and not dy dx. If it doesn't bother you, you don't necessarily have to change it for the slope field, but you do for the separation of variables. So I'm just going to rewrite it. So really it's telling us dy dx equals 1 over y. First thing that stands out to me about this derivative only depends on one variable. It only depends on y, not x and y. That's going to make it easier. That means if I choose any time, well, what happens when y is 0? Undefined. So anytime y is 0, that would be the whole x-axis. I would have like vertical tangents. Undefined would be vertical. Notice they don't put any points there. They never have us sketch the points where there would be a vertical tangent, so they just leave those points off. But I'm going to go upper row, right here. On that entire row, y is 1. If I let y equal 1, what's the slope? 1. So I get to all of those points all at one time because there isn't an x. It doesn't matter what x is. If y is 1, all of these slopes are 1. So it makes it a lot easier when it's only dependent upon one variable instead of 2. Okay. If I go to the next row, here y is 2. If I plug in 2 for y, what's the slope? Good. So when I sketch it, just relative to this one, it should be a little less steep. Okay, so I'm just gonna make it a little less steep. I don't know, maybe about like that. What's the slope when I go up to 3? A third. So the further we go this way, it's getting less and less steep. So just relative to each other, we should kind of recognize it's getting less steep. Okay, what if we go to where y is -1? -1. So it's like a 45-degree angle. If we go to -2, the slope would be -0.5, and so on. Another thing that stands out to me is this slope field question is symmetrical about the x-axis. So once I know the top, I can tell the bottom is like just been reflected. So that's a good enough slope field. Okay, so we've done part A. Your assignment is going to take you through these very similar steps. In this assignment, it's one where you have like this tear out page where they give you the graph, so you guys don't have to tear it out, you take a picture, but you can like do your work in your book, or at least, yeah, I'll put it so. Okay, so it's going to have similar. So you're going to draw the slope field. Part B, they want us to graph the particular solution through those 2 points. Those are 2 separate particular solutions. So if I graph the particular solution through the point -2, -1, I'm going to go -2, -1. I'm going to plot a point there. I'm going to try to graph a function that would follow the slope field of this. I can't cross where it's undefined though. So it's going to go to where it's undefined, but I'd expect like an open circle. It looks like the further we go away from the x-axis, the less steep it gets. So it's just flattening out. That would be a good enough curve. But the further we go, it's flattening out. The slope is always negative, it's always decreasing, but it is flattening out. If we go to the point 2, 2, a separate point, a separate solution, 2, 2, so I plot a point at 2, 2. Kind of follow the same thing as I go this way, it's getting until it goes vertical, and out this way, it's less steep. What do those 2 graphs look like? What type of function? Square root. Because it stops and it doesn't keep going down, it makes me think it's a square root function. So on C, they want us to solve the differential equation. So to solve the differential equation, I'm taking the dy dx equals 1/y. Step number 1 is separate the variables. So I have to move the y over to the side with the dy. So I'd have y times dy equals 1 dx. So I separate the variables. Then I integrate each side or take the antiderivative. The antiderivative of y is y squared over 2. The antiderivative of 1 is x plus c. We're going to get y by itself. So I would multiply by 2. If I multiply by 2, I'd have y squared equals 2x plus 2 times a constant, but that's still just a constant. I'll take the square root. So I get y equals plus or minus the square root of 2x plus c. So right now I have to leave it as a plus or minus until I'm given a point to help us decide which one it is. Okay, so if I do the point -2, -1, that means I'm taking this equation, the plus or minus, this equation we just found. In place of x, we're putting in a -2, and in place of y, we're putting in a -1. Do we choose the plus or the minus in front? The minus. Y is negative, so we have to choose the negative. So -1 equals negative square root of 2 times -2 plus a constant. Or -1 equals negative square root of -4 plus a constant. I would just divide both sides by a negative to get rid of that. Undo a square root by squaring it. So 1 equals -4 plus c, where that constant is 5. Your final answer has to be your y equals, because somebody else's work might look different. So your final answer is y equals, we said there's a negative in front, square root of 2x plus 5. If we were to graph that, that graph is exactly this graph right here. The negative square root, which is why it's below the x-axis. So when I do the next point, because y is positive, I get to plug it into the equation with the plus sign in front, so the positive of that. I'll plug in 2 for y, 2 for x, and now solve for c. Undoing the square root, we can square both sides. So 4 equals 4 plus a constant. So this time the constant comes out to be 0. My graph wasn't great, but it would have been acceptable. So y equals the square root of 2x, which I just adjust my graph and it goes to the origin. It looks more like that. Because the square root without a, it didn't have any horizontal shift. But just so you know, if you graphed what I did originally, you would have still got it. Just so you get to see the basic shape. All right. So again, today we're pretty much just practicing still solving differential equations and just seeing a visual representation of it. These last 2 examples are examples of how it's going to come up on a multiple choice test. These are often multiple choice. We as teachers hate grading your differential, your slope field pictures, and much as you hate sketching them. So at most you're going to have one. They're more likely to come up as multiple choice where you're provided the slope field and then asked to match which differential equation goes with it. So I look for patterns. So with this one, when I look at this slope field, something stands out to me. It stands out to me that the slope is the same for all of the values of x. You guys see that? Or like the whole way over, it's always the same. So looking at this, I make a note to myself that the slope only depends on one variable. Does it depend on x or y? Does the slope change as x changes, or does the slope change as y changes? As y changes. As you go up, the slope is getting steeper. As you go down, it's getting less steep. So slope only depends on y. That means the equation can only, the derivative can only have a y in it, not an x and a y. It's not changing when x changes. So I could easily eliminate a. So it has to only depend on y, so my options are b and d. So I'm already down to just a 50-50 chance here by just looking at that. Then you can just plug in numbers. I mean, if I pick any point, let's say I go to this point right here. That point is at 2, 2. If I plug in 2, I get a slope of 2. Or over here, what would the slope be if I used this one? 5. I don't know. Maybe that's a slope of 2. Maybe it's a slope of 5. That's too hard to tell. I want to look for something that would be positive versus negative. So what if I chose a point down here? What if I chose that point? That point has an x value of 2 and a y value of -1. So what's the slope if I chose b? What's the slope equal to at that point? So if I take this, dy dx is y prime, dy dx equals y. But if I evaluate it at the point 2, -1, what's the slope? -1. It's the y value, right? Is the slope at that point -1? No, it's positive. It's clearly not negative, so it cannot be that one. Because this slope, anytime you plug in a negative value for y, we would expect a negative slope. But the other thing that stands out to me, this entire, every point has a positive slope. Well, when you square something, that's always positive. So this one seems reasonable because you're always going to end up with a positive slope. And the slope at every point in that picture is positive, so I know the answer is D. Okay, but when in doubt, just pick a point and see if the slope matches until you find enough where you feel confident that it either does or does not match. Okay, example 7, they switch it just slightly. They still give us a differential or a slope field, but instead of telling us what y prime equals, instead of telling us the slope, they're giving us a y equals equation. So these should be the graphs that we can graph on top that would follow the slope field. So I'm going to sketch each one of these just like a little sketch next to it. The graph of e to the x, we should know what that graph looks like. E to the x looks like this. Would it be reasonable that this graph, e to the x, could be sketched on top? Would it follow the slope fields? You see how that's an easy no. If I tried to graph e to the x, clearly does not match the slope. Okay, so this one is definitely out. E to the negative x, what does a negative inside a function do? What reflection? Across the x or across the y? Across the y. So now it's like a decay function, it's coming down. Is that possible? That's in the running. So I'm not confident enough 100% that I'm going to choose it yet. I'll keep going. The negative in front of e to the x, that would be a reflection down. So it's like a, except for the reflection across the x-axis. Anyway, that can match? No, so that one's clearly out. Negative ln, That's our natural log graph. Natural log normally looks like this. Throwing a negative in front flips it. So negative ln of x starts high and comes low. Ln of x is only defined for values, for positive values of x. And here we have values over here. So it can't be there because it's not defined for negative values of x. So it doesn't work there. And then ln of x, kind of the same reason. So yeah, this one is B. It's the only graph that we could actually sketch on top that would fit the slope fields. Okay, so your assignment today is questions 1 through 10. So 7.3, we're gonna call it 7.3a, so we're gonna break this down into two, because a lot of these questions do have like a part A, B, C, D. Okay, so it says on number 1, find the slopes of the differential equation at each of the following points. But again, this is a assignment where they give you a page in your book, so you're welcome to like tear it out if you want to. You don't have to keep flipping back and forth. You just take a picture and turn it in, whatever works for you. But you can just write your slopes there. That way, when it's time to sketch your slope field, you can just sketch it on top of those dots and don't have to create your own little grid. Okay, I believe this paper goes 1 through 10, so you're just doing the first 10 questions on here. What you'll notice, so number 1, again, each one kind of has a lot of parts to it. 1, you're just plugging in the point and stating what the slope is. When you get to 3, it's very similar to what we did on our examples. You're going to plot the points, plot the following points, graph the separate solution curve. So you're just graphing if the slope field is already provided, you typically just have to draw the curve on top of it. And then you're going to be solving the differential equations. There's like a lot of the solving differential equations throughout. Okay, so I'll let you guys work. The other thing I'd like you guys to do tonight is I unlocked the final multiple choice questions from last week. Take a look at that, and then tomorrow we'll go through some of the most missed questions or ones that you guys don't understand. So you can look at it, you can see what the correct answer is. If it makes sense, great. If it's one you don't understand, then just come prepared tomorrow to talk about questions from your final. So, all right, again, if you've not filled out that survey about the groups, if you'll do that by like lunchtime, so that this afternoon I can make a seating chart for tomorrow, that would be great.